Year 11, it's Miss Hughes. This is a really quick video just because I've had quite a few questions about how to calculate the number of subatomic particles in the different elements on this worksheet. So the first thing I'm going to do is just put a new slide in, and I'm going to go through a little bit of information. So from the other task, you will have labelled the atom. So you know that there are 3 subatomic particles. There are protons, neutrons and electrons. Now we can use the numbers on the periodic table to determine how many protons, how many electrons and how many neutrons are in each element. So if we do carbon, there are 2 numbers associated with carbon. We have 6 on the bottom and we have 12 on the top. Now the first thing I'm going to just talk through is the fact that this number here is the proton or atomic number. So I'll write this dead quickly. You've got the proton number or the atomic number. The number on the top is our relative atomic mass, so the mass of that element. Now, this bottom number, and this is not a trick, it is not a trick at all. Everyone always thinks it's some kind of trick because chemistry is never this easy, but this bottom number is the number of protons and electrons. Okay, so that number will tell you how many protons it's got and how many electrons it's got. Now if you were doing electron configuration, you will know to come to this proton number, the bottom number, the smallest number, and it will tell you how many electrons there is, and then you can go and do your electron configuration. But it also tells you how many protons are in the nucleus of the atom. Now this top number tells you how many protons plus neutrons there are, and the reason it does this is because protons and neutrons each have a mass of 1. So you have 6 protons that have a mass of 1, and then the rest of the mass is made up of neutrons. So let's put the table in. Obviously the table looks much better than mine, but you have appearance, which is just the symbol. So for carbon the appearance will be C. You have the protons, electrons, and finally you have neutrons. Now I've told you straight away that it's no trick. This bottom number tells you the number of protons and electrons. So we have 6 and we have 6, and that is for every single element. So whether it's lithium that has 3 electrons, it would have 3 electrons, 3 protons. Sodium has 11 electrons, it will also have 11 protons. Now your neutron number, you have to do a little calculation. So we know our proton number is 6, and what we are going to do is we are going to take our proton number away from our mass number. So we're going to take 6 away from 12, which will give us a total of 6. So there you go. For carbon it is 666. Now let's do another one really quickly. Let us do sodium that I've already mentioned. So sodium is 11 and its mass is 23, I believe. So if we talk about what I've just said and I'll quickly draw that table, straight away you are going to be able to say, right, Miss Hughes has said that that bottom number is always, every single time, the number of protons and electrons. So it has 11 protons, but it also has 11 electrons. Now for your neutrons, I'm going to do that quick calculation, and I'm going to take 11 away from 23, and that leaves me with 12. So that is how you work out the different subatomic particles in each of your element. If you have completed it and you do want to send it through for me to check, I'm quite happy to spend a couple of minutes going through the first few and making sure that you've got this principle down. Hope this helps, and any other questions, just keep emailing me and let me know. Bye.